Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome back to our online lecture series on electrical machines. This is Muhammad Owais, your course instructor. The weekly schedule for our online lectures for this course, the major references, and your textbook. So transformer was the topic which we were discussing previously, and we are continuing with the same topic. So students, if you remember, our previous lecture was a relatively a dry topic, and it must have been difficult for you to understand those topics. But the good news is this, okay, that is over. And now this part of our course or this particular video should be a relatively more interesting and easier for you to understand. Okay, so now we are discussing and we are moving towards the equivalent circuit of a transformer. So please remember that the following effects have to be accounted whenever you are considering for a transformers model. And these effects are the copper losses, the leakage flux at the primary and secondary, and the core excitation effects. Okay, fine. So let's start with the copper losses. These copper losses are actually the ohmic losses, I square R losses, and these are actually modeled by resistors on the primary and the secondary sides respectively as RP and RS. Now if you talk about the leakage flux, this leakage flux phi LP and phi LS, we discussed about this leakage flux in the previous lecture. These are modeled by self-inductances, okay? So these are represented by self-inductances LP and LS. And what we do is we use models in our model. We show them as reactances XP and XS. Okay, so that we can give the relation between voltage and current. Lastly, is the core excitation effects. These are just approximation. Remember, basically a very non-linear effect, but with some assumptions we have discussed that IM is the component, is the magnetization component, or the component which ensures that the core remains magnetized, and it's the component which is actually out of phase. It lags voltage by 90 degrees. Okay, so since it resembles the characteristics of an inductor, what we do is we model it by a reactance Xm. Okay, this is the effect which is shown at the excitation in our excitation branch on the primary side. The other part is the core loss current component. This is in phase component, and since the voltage and current relationship they are in phase with each other, and they are just like a resistor. The characteristics they do can be modeled by a resistor RC. So it has been replaced by a model resistance RC. So students, here is the summary of the previous slide. Here I've shown you the equivalent circuit diagram. This is called the equivalent circuit of a real transformer. Yeah, you see this written here as ideal transformer, but this is referring to this block. Okay, and all the other components are actually representing a real transformer. So you can see primary resistances, you can see reactances in primary and secondary, and apart from that you can also see the excitation branch. This is your excitation branch. You see, this is the resistance RC. Okay, modeled by resistance RC, and this is a component which is in phase with the voltage, as you can see from here, whereas XM is the out of phase component represented by reactance. Okay, so this was the part of the excitation. This is your excitation branch, and the two parts are these RC and XM. RP and RS, as discussed previously, represent the copper loss component modeled by their resistances, and XP and XS are the reactances. So with this, we now have our model with us. The primary voltages are shown here, and the primary current, you can also see this. The dot convention has been followed. So on the secondary, you see that the secondary current is flowing out of the dot as per the dot convention which we discussed in our very first online class. So before we proceed and continue with our discussion on equivalent circuits, and you shall see we will be discussing different types of circuits which model the transformer. This is just a summary of some previous relation which we have used frequently. So this was the relation Zp is given as A square into Zs, where Zp is the resistance at the primary side and Zs is the secondary. So if you ever wish to refer the secondary impedance on the primary side, then this is the relationship which you shall be using. And interestingly, the same relation are used for the inductances and for the resistances as well. So if we want to refer the reactance from secondary to primary or from primary to secondary, we shall be using the same relationship as defined for the impedance previously. Okay, students, so it's time to introduce you to some different variants of equivalent circuit of a transformer. So the equivalent circuit can be seen here. You see it's exactly the same as we discussed in the previous slide. Now, you would also remember that in our first online lecture, we discussed how to transform an impedance from one side of the transformer to another side of the transformer. Specifically, we discussed how can an impedance at the secondary be transformed to the primary side using the relationship given by Zp is equal to A square into Z of S. So now we can do the same by simply referring all the impedances to the primary side of the transformer. Let's do this here as well. So you can see what do we have at the secondary? We have resistance, we have a reactance, and we have the secondary current and the secondary voltage as well. So let's transform all these parameters to the primary. Let's do it. So this is shown here. You can see there is no change in the primary resistance, the primary current, the primary voltage, nor is there any change in the excitation branch. The only changes are here. You see the secondary resistance which were on the secondary side have now been transformed via A square into R of S. We multiplied the resistance with this relation of A square. Okay. So with this we are able to transform the impedances to the secondary. Same for the reactance as well. And as far as the current is concerned, this has been done using the relationship which we discussed previously, and same for the voltage. So I hope ये relation आपको clear है कि हमारे पास ये relation किस तरीके से दे रहे. So if you are facing any problem, please refer to our previous slide. ठीक है students? Okay. Now these resistance we can simply give them a name as RP steric, and similarly LP steric or VP steric. It's up to you whether you want to write it down like this or not. Okay, so this steric means actually it has been referred to the other side of the transformer. For instance, RP steric will refer to secondary resistance that has been referred to the primary side. Okay, so this resistance is nothing but my RP steric. So I hope this is clear to you. Similarly, this will be now LP steric, where steric would mean that this is not actually a primary reactance or impedance. In fact, it has been referred to the primary side. Okay, students, so the same can be done by simply referring the primary resistances, impedance, and the current and voltages to the secondary side. So let's do this. So let's first analyze what do we have at the primary side. Apart from the series resistance and the reactance, we also have the excitation branch here. This is your excitation branch. So this also has to be referred to the secondary. And let's see how we can do this. We use the same relationship as we did previously for referring resistances and impedances to the primary side. Okay, now for voltages and currents, you have to make sure that you use the right relationship. And these relationships are the very basic which we discussed in our previous slides. This is the circuit. You can see this is pretty straightforward. So all the parts, all the components from the primary have been referred, and you can see that the values have changed. So voltage VP is now written as VP over A, and current is given by A into IP. So again, continuing with the same practice as we did previously, we can write all these things like this as well. Let me write this out first. Okay, so for instance, RS steric would mean the primary resistance which now has been referred to the secondary side. Although we have simplified models by referring uh, models either to the primary side or to the secondary side, but still these may be a bit complicated for some of the engineering applications. So we can still afford to simplify these circuits further. So, for instance, if you look at the circuit shown here, now this circuit is actually a circuit of a transformer equivalent circuit, which has been referred to the primary side. Now, if you see this excitation branch, this actually creates an extra node at this point, which makes the analysis a bit more complicated. And since the current in this excitation branch is very small, and there is essentially hardly any drop across the resistances RP and the reactance XP, so we can simply just ignore this part, or we can simply ignore the drop, and we can just move this around to the left, and we can simply add the resistances together, which means that RP and A square RS will get into series with each other, as can be seen here. You see, this has been shifted to the left side, and now you have an equivalent resistance and an equivalent reactance. Obviously, this is with some compromise, but this essentially makes the circuit quite simple for analysis, and it works good enough, okay, for most of the applications. So this equivalent resistance is, as can be seen, is simply let me draw this for you. Okay, so in this, the resistance which we have are RP. This is my resistance. This is another resistance, and the reactances are here. It's P. So you can simply add these together. This has been shown here, if you see. So R equivalent at the primary side is R equivalent primary is RP plus A square RS. So the same can be done if you refer the model to the secondary side and simply ignore the excitation branch and move it towards the left side again. Let's do that, but before let me rub this out. ठीक है स्टूडेंट्स, आई होप ये चीज आपको समझ में आ गई है। ये जो हमारे पास ब्रांच थी एक्साइटेशन ब्रांच, इस ब्रांच की बात कर रहे हैं जी। ये एक्साइटेशन ब्रांच में जो करंट जा रहा है दिस इज सिग्निफिकेंटली लो, बहुत कम करंट होता है। तो इसकी वजह से जो हम एसोसिएटेड जब ड्रॉप की बात करते हैं, यहाँ पे ड्रॉप ना होने के बराबर होता है। तो हम कहते हैं कि जब यहाँ ड्रॉप है ही नहीं तो हम इसको यहाँ कंसिडर क्यों करें, तो हम इसको हम यहाँ इस साइड के ऊपर लेकर आ जाते हैं, ठीक है। और उसके बाद होता है क्या है कि एसेंशियली ये पार्ट हमारे पास यहाँ मूव कर जाता है, which makes RP and A square RS in series. Okay students, fine. तो आई होप ये क्लास आपको थोड़ी सी कंपैरेटिवली आसान लग रही होगी। Okay, so we are done with this. Again, now here you see ये जो circuit आपके पास, this circuit has been referred to the secondary side, and again this excitation branch can be moved this way. So this excitation branch can be simply shifted here. Okay, let's do this. और जब हम कर लेंगे तो आपके पास सर्किट यहाँ पे हो जाएगा। दिस इज अनदर सिंप्लीफाइड मॉडल ऑफ transformer when it has been referred to the secondary side. So the point is there is a point here is that we are doing all this to simplify our analysis. So अगर simplification चाहिए तो आप बिल्कुल simple model भी use कर सकते हैं, और इनफैक्ट अभी जो आपको मैं मॉडल्स दिखाने जा रहा हूँ उसके अंदर आप simply एक्साइटेशन ब्रांच को आप इग्नोर कर सकते हैं कि एक्साइटेशन ब्रांच को आप कंसिडर ही ना करें, ठीक है। ओके, सो ये आपको आप देख सकते हैं कि इंटायरली हमने क्या कर दिया, एक्साइटेशन. So student, this is the summary of simplified models. The models which you see here at the top, these are actually models in which excitation branch has been considered. Although we have moved the excitation branch to the left, हम left पे लेकर आ गए. क्यों लेकर आए? To simplify our analysis. ठीक है? And but we, as we discussed in previous slide, हम इसको simply ignore भी कर सकते हैं. And these models down here you can see they do not actually include the excitation branch. So we shall see in our applications whether we are going to use excitation branch or not. But generally जो model हम ज़्यादा prefer करते हैं, जो हम लोग use कर रहे होते हैं अपनी applications में, वो ये models हैं. ठीक है, इन models की मैं बात कर रहा हूँ. तो ये इनको हम इस वजह से use कर रहे हैं क्योंकि हमें core loss component भी चाहिए होता है, और वो जो कोर लॉस कंपोनेंट है वो हमें फ्रॉम एक्साइटेशन ब्रांच ही मिल रहा होता है. सो वी शैल बी स्टिकिंग मोस्टली टू दीज सर्किट्स और दीज टू सर्किट्स. जो आगे चल के आप अभी देख लेंगे कि हम किस तरीके से इनको एग्जांपल्स में यूज करेंगे. Okay, students, now is the time to discuss some very important tests. These are the tests which are conducted on transformer. The very first of this test is called the open circuit test. Why is it called open circuit test? Because actually in this test what we do is we open one side of the transformer. Generally the secondary is open circuited. Secondary को हमने यहाँ पे open circuit कर दिया है, and we have applied a full rated line voltage. ठीक है, so this voltage is actually a full rated line voltage. ठीक है जी, full rated line voltage हमने अप्लाई की है. And remember the secondary has been kept open circuited. And what we do is this is uh, how we connect our components. We have a voltmeter and a meter, and we have a wattmeter. ठीक है, so we are interested in finding out the input current, the voltage, and the power. Okay, once we do this test, let's see how we analyze the circuit. Now here, this is the equivalent circuit which has been shown here. What we do is we have referred the transformer's equivalent circuit to the primary side. Since there was nothing on the secondary, there was no current flowing into the secondary winding, so there was no drop, there was no losses in the secondary windings. So वो windings को हमने यहाँ नहीं दिखाया. There is no need to show those windings. Okay, which means since is 0, steric is 0. Why I have written it as steric? Because this is the current referred to the primary side. Okay, now this is your primary is exactly the same. There is one assumption though. Since we discussed previously that since the secondary is open circuited, then there is a very small current. Okay, so since the current is very small, then the voltage drop across resistances Rp and this reactance Xp is negligible. And since this voltage drop is negligible, we simply can remove this part from our equivalent circuit. Okay, so this circuit will simply uh, be just the excitation branch. ठीक है, ये चीजें आपको यहाँ पे बताई गई. और चूंकि ये करंट जो हमारे पास होता है, दिस इज जस्ट a few percent of full load current. ठीक है, as you can see here, just the few percent of my full load current. Okay, so then my total impedance in the circuit is given by, this is my total impedance. Z open circuit is Rp, this resistance, plus JXP here we are, and then plus the combination of the parallel combination of the excitation branch impedances. So RC is in parallel with JX of M. Okay, students, now let's find out the impedance, the total impedance in the circuit. हमने ये पीछे भी discuss किया था, if you remember. This is my total impedance in the circuit. But the point is that these resistances, the voltage drop across the resistance is essentially zero, which means that we can ignore these resistances since the excitation current is very small. Okay, as you can see here, so the voltage drop across Rp and this JXP can be neglected. And when we do so, this is our total impedance in the circuit. Then This we know is simply now the parallel combination of these two impedances. If this is the impedance, okay, then we know that admittance is given by the reciprocal of my impedance. So if I want to write down the admittance, then that admittance is given by this relationship. So you might be a bit confused that how did we get this relationship? Hmm? So from where did we get this relationship? So for this you need to do some small mathematical analysis. It's pretty simple. But let me do this for you. So have a look here. If you see, this is your impedance RC parallel with J of Xn. So you can write down this relationship as like this. So 1 over Z is equal to this term. And since admittance is the reciprocal of the impedance, therefore this relation simply becomes Y is equal to 1 over RC minus J into 1 over Xn. So we define these two parameters as G of C and B of M. And if we compare these two together, we will see that G of C is equivalent to 1 over RC and B of M is equivalent to X of M, where this G of C is the conductance while B of M is nothing but the susceptance. And how do we get this minus है? Because आपको मालूम है कि this J component जो कि iota है, अगर मैं इसे ऊपर लेकर जाऊंगा तो this plus will get converted into a minus. So I hope now this is clear to you that how did we get up this relation. Okay students, let's continue our analysis of this simplified circuit with just the excitation branch. So you know that the magnitude of excitation admittance, which is the reciprocal of the impedance, this admittance magnitude can be given by Y of E is equivalent to IOC divided by VOC, where IOC is the current that is flowing into the primary when the secondary has been open circuited, whereas VOC is the voltage that has been applied at the primary when you have open circuited the secondary. Okay, now what about the angle of admittance? Now this angle of admittance can be found from the knowledge of the circuit power factor. And the open circuit power factor is simply given by, this is the relationship or the relationship for power factor, cos of theta. And this is given by this relationship. So because power at transformer's power is given by voltage into current multiplied with cos of theta, so we can simply manipulate this relationship to find out the power factor. And once I have the power factor, I can find out the angle. Okay, so the angle of admittance can be found using this relationship. Now that I have my angle of admittance, I have the magnitude of admittance, I can find out the admittance now. This admittance is simply given by this relationship. Okay? So IOC divided by V of C. So the power factor, since the power factor is always lagging for a real transformer, so the angle of the current always lags the angle of the voltage by theta degree. Therefore, you see this relationship, this minus here. Okay. So I hope now this is clear to you. Now since we also know that the relationship for admittance is given by this, so अगर हम इन दो को आपस में compare कर लें, इन दो equations को, so I can find out the value of my RC and the value of XM. Okay, so simply these two equations can be compared. I can find out the value of the excitation branch components. So you see इसके जरिए से हम पूरी excitation branch की जो value है जिससे मॉडल कर रहे हैं उनकी values को निकाल सकते हैं. And once we get the value of this, we are able to find out the core losses. तो ओपन सर्किट टेस्ट जनरली जो हम करते हैं वो किस लिए करते हैं जी, टू फाइंड आउट द कोर लॉसेस, क्योंकि कॉपर लॉसेस ऑलरेडी बहुत ना होने के बराबर है. एक इंतहाई सेकेंडरी के ऊपर देयर इज नो करंट फ्लोइंग, सो देयर आर नो कॉपर लॉसेस इन द सेकेंडरी. और आपके पास जो लॉसेस है वो कहाँ पर है, प्राइमरी के ऊपर है, जो बहुत ही माइन्यूट ना होने के बराबर है, क्योंकि एक्साइटेशन ब्रांच में जो करंट है वो इंतहाई कम करंट है. Okay, students, now let's move on to the second test, which is called the short circuit test. So now is the time to discuss the short circuit test for transformer. And when we, as the name suggests, short circuit means that one side of the transformer is simply short circuited. So here you see the secondary has been short circuited, and we are interested in finding out the voltage at the primary, the current at the secondary, and also the power. And the important point is this, that the voltage that you are going to apply here, okay, here, it's not the rated voltage. So it is simply voltage at the primary. It is adjusted until the current in the short circuit winding. So current here, this is the short circuit winding, until this current reaches the rated current. So you simply start increasing your voltage and you stop when the current in the secondary is actually it has reached the rated current. Now, during the short circuit test, the voltage that is applied at the primary side is very low. It's only a few percent of the nominal or rated voltage. Okay, now if this voltage is low, then the excitation current which is flowing into this excitation branch, this is almost negligible. Okay, so for simplification, we shall simply uh, ignore this excitation branch, which means that the resistances will simply be added up together. And since the applied voltage is very low, the core losses are also negligible as they depend on the input voltage. And as discussed in the previous slide, the resistance they simply add up together. So what we have some resistance which are in series with each other. So this is the simplified impedance. So you have rp plus jxp plus rs steric plus jx of s steric. Again, the steric actually refers to the resistance which has been actually referred to the primary side, and same is the discussion about the secondary reactance. And we also know that Z secondary is given by this relationship, R equivalent plus J equivalent, and this is given by this term. So RP plus A square R of S. So what is this A square R of S? This term is nothing but the resistance of the secondary which has been referred to the primary. ठीक है स्टूडेंट्स. चले जी, अगेन हम बिल्कुल उसी तरीके से जैसे हमने ओपन सर्किट में किया था, वी आर गोइंग टू डू द सेम here as well. ओके, सो मैग्नीट्यूड ऑफ सीरीज इम्पीडेंस कैसे निकालेंगे जी? बहुत आसान है जी. वी वोल्टेज डिवाइडेड बाय द करंट, वोल्टेज शॉर्ट सर्किट करंट डिवाइडेड बाय शॉर्ट सर्किट करंट. सो दिस वीएससी मींस द वोल्टेज, ये वो वोल्टेज है जो हमने प्राइमरी के ऊपर अप्लाई किया है, ठीक है, डिवाइडेड बाय द करंट व्हिच इज फ्लोइंग इनटू द सेकेंडरी फॉर दिस पर्टिकुलर सेटअप. अच्छा जी, पावर फैक्टर बिल्कुल उसी तरीके से आप निकालेंगे जैसे आपने ओपन सर्किट में किया था, एंड यूजिंग द सेम रिलेशनशिप यू कैन फाइंड आउट द वैल्यू ऑफ the angle, ठीक है, the impedance angle. This is your impedance angle, and once you have the angle, you have the magnitude, you can simply find out the impedance now. And this impedance is given by this relationship, voltage divided by the current, and what you get is this simplified relationship. If you compare it with this relationship, these two relationships together, so what you get is the value of the equivalent resistance. So you shall be able to find out the value of equivalent resistance and equivalent reactance. Obviously, you will not be able to find out the value of RP and these two resistances separately, but luckily we do not need them for simple calculations. Okay, students, theory बहुत हो गई है. Now is the time to solve an example, a very interesting example and a very simple example. हमें यहाँ पे एक सेटअप गिवन है ट्रांसफार्मर का. सो द इक्विवेलेंट सर्किट हमें कहा गया है ऑफ इक्विवेलेंट सर्किट इम्पीडेंसेस ऑफ अ 20 kVA. तो ये क्या है मेरे पास? दिस इज द apparent पावर ऑफ द ट्रांसफार्मर. So the primary voltages and secondary voltages are also given. The frequency is also given. Now the open circuit test and the short circuit test were performed on the primary side of the transformer. This is important, ठीक है? प्राइमरी साइड के ऊपर हुआ है, जिसका मतलब है कि हमने सिंपली किया क्या है कि हमने सेकेंडरी को ओपन किया है और सेकेंडरी को शॉर्ट सर्किट किया गया। ये इन्फॉर्मेशन आपको बता दी गई है कि टेस्ट कहाँ पे हुए हैं। ये दिस इज वेरी इंपॉर्टेंट स्टूडेंट्स, प्लीज पे अटेंशन एज वी डिस्कस दिस। दिस इज इम्पोर्टेंट, सो यू नीड टू नो कि वो जो टेस्ट हुए वो कहाँ पे हुए। सो वो प्राइमरी में हुए या सेकेंडरी के ऊपर हुए। यहाँ पे आपको बता दिया गया है कि दीज टेस्ट हैव बीन कंडक्टेड ऑन द प्राइमरी साइड ऑफ द ट्रांसफार्मर। ठीक है जी। मतलब क्या हुआ, यानी जब हमने ओपन सर्किट किया था तो हमने सेकेंडरी को ओपन कर दिया था, और जब हमने शॉर्ट सर्किट किया था तो हमने सेकेंडरी को शॉर्ट सर्किट कर दिया था। जितनी हमने वैल्यूज निकाली है वो सब कहाँ निकाली है, पैरामीटर्स की, वो हमने प्राइमरी साइड के ऊपर निकाली है। So what are those values? These are the values here. So open circuit voltage is given, the open circuit current is given, power is also given, and same is the information about the short circuit test. What are we supposed to find? We have been asked to find out the impedances of the approximate equivalent circuit, refer to the primary side and sketch the circuit. So we have to find out the values of all the impedances on when the circuit has been referred to the primary side. So let's proceed with this. ओके जी स्टूडेंट, सबसे पहले हम ओपन सर्किट टेस्ट को देख लेते हैं। रिमेंबर स्टूडेंट, जब भी हम ओपन सर्किट टेस्ट कर रहे होते हैं तो हम जो रिलेशन यूज करते हैं वो हम एडमिटेंस का यूज करते हैं। ठीक है, इसके पीछे रीजन क्या है, क्योंकि एनालिसिस बहुत सिंप्लीफाई हो जाती है। आप चाहें तो आप इम्पिडेंसेस भी यूज कर सकते हैं, बट दिस रिलेशन इज रिलेटिवली मोर सिंपलर। ठीक है जी, चलें जी। सो दिस इज माई पावर फैक्टर, वी नो दिस रिलेशनशिप। ये रिलेशन कहाँ से है हमारे पास, दिस इज द रिलेशनशिप for the admittance, but we first need to find out the values of the power factor. क्यों? क्योंकि I know the value of open circuit current, I know the value of open circuit voltage. Let's find out the power factor. Is given by the same relationship, cos theta is equal to POC divided by VOC IOC, and luckily I have got all the parameters with me. Simply by putting in the values I can find out the values. This means the power factor is 0.34. ठीक हो गया जी। Once I have the power factor, I can simply place the value here and find out the value of the admittance. ठीक है जी, मैंने यहाँ place किया है and then I have simply solved this. And now since I know that admittance, this admittance is also equal to this relationship जो हमने पीछे पढ़ा था 1 over RC minus J 1 over XM. ठीक है स्टूडेंट्स, so using this relationship simply हमारे पास RC की वैल्यू आ जाएगी। we now have the value of RC, we also now have the value of XM, which means the excitation branch components have now been identified, referred to the primary side, but since they were already on the primary side there was no need to refer these parameters. ठीक है, so अब RC और XM आ चुके हैं, let's proceed to the next step. ओके जी, नाउ वी डू एग्जैक्टली द सेम फॉर द शॉर्ट सर्किट टेस्ट एज वेल। इंतहाई आसान सवाल है। ठीक है, तो शॉर्ट सर्किट टेस्ट के अंदर हम जो बात कर रहे होते हैं, यहाँ पे हम इम्पिडेंस की बात कर रहे होते हैं। प्लीज रिमेंबर, ओपन सर्किट टेस्ट के अंदर वी वर डिस्कसिंग, we use the concept of admittance, that we started with admittance, it's just for the sake of analysis. Okay, so again we have to find out the value of power factor, because the voltage, short circuit voltage and short circuit current are given. ठीक है, why do we again have to find out the value of the power factor? Again, because we are now discussing short circuit test, that was the data for the open circuit test. ठीक है जी, so now again using the same relationship we have now again our power factor with us. By simply placing this value into my equation for the impedance, I can find out the value of my impedance. Now I have this relationship. Okay, so this is my real part and this is my imaginary part. And in the previous slide we discussed another relationship of the impedance when we are talking about the short circuit test. So ये मेरे पास, this is one equation, so this is my equation 1 maybe, and this is my equation 2. So if I simply relate these two together, I will be able to find out the value of R equivalent and X equivalent. यही हमने किया है, इनको relate किया आपस में. And using this relation, we have now successfully found out the value of R equivalent and X equivalent. And so the last part is to simply draw the circuit. हम सब हर चीज को हमने प्राइमरी के ऊपर रेफर कर चुके हैं, चीजें इंतहाई आसान हो जाएंगी हमारे पास. ठीक है जी. Now this is my final circuit. You see, when every part has been referred to the primary side. So this is my RC, this is my JX of M component, this is the equivalent resistance, and this is my equivalent reactance. Remember, we have used the simplified version with excitation branch. So this is how we conduct open circuit test and short circuit tests. So by the end of this chapter, inshallah, I will be posting some exercises from the end problems. So I think once you do those problems, your concepts will get even better, inshallah. So that's it for today, students. I hope you were able to understand the concepts. If you still have any problems, do write me an email, and inshallah I will reply you back and I will answer your queries during our interactive session. Inshallah, I shall see you in our next video session. Till then, take care of yourself and your families. May Allah be with all of us. Ameen.